George, can you hear me? George, can you hear me? Hello, George, can you hear me? Is this any better? This is better? Good, good. We're going to get started? Okay. Hi, folks. Welcome to the Future Data Meetup. Thanks for coming out tonight. My name is Rafael Cos, and I'm one of the co-organizers for this meetup. So tonight we have a full agenda for you, talking about enterprise data science at scale. We have some speakers from Hortonworks and from IBM, and we have a demo in the middle of it. So we'll keep our fingers crossed and pray to the demo gods and make sure that all goes well. So our first speaker is from IBM. He's Josefa, who's one of the product managers on DSX. So with that, please welcome him.
So hopefully with the projector going wrong, the demo will go okay. You know, it'll just work out. So before we get started, any data scientists in the room? Or people working with data science issues? So a couple of them here. Quite a few, actually. Awesome. So presenting along with me today is Vinay. Many of you may know him. He's the director of product management working on data science. I have a couple of colleagues here. Vikram Murali, who is the program director of development for data science experience. And I've got the architect, Sriram, who's sitting down here, who's also the architect for data science experience. So let's spend a little bit of time in terms of why we got IBM and Hortonworks together. So many of you know Hortonworks is has a big distribution of Hadoop. They're big contributors to the open source platforms. IBM, on the other hand, we are leaders in data science experience. We're leaders in solutions on the hybrid cloud and on-prem. So bringing together the expertise of Hadoop in data and IBM's expertise in data science experience and Big SQL, our intent here is to create integrations that help you solve or accelerate your data-driven analytics issues. But overall, our intent is to bring data science to the Hadoop workloads to help you solve that problem at scale. Now, when you look at the general data science lifecycle, this is a very iterative process. It goes from defining the problem to taking a look at the data, transforming the data, learning from the data, creating models, deploying it, and then the circle goes around, mainly because once you deploy the models, we know that over time, the performance of the model degrades. You have to, again, train it using new sets of data, put it through this entire life cycle again. Once you put it into production, you may get new requirements, because of which you may have to run through the entire workflow, the life cycle one more time. Also, there are various users who are involved in this entire life cycle. You've got data scientists, you've got data engineers, you've got business analysts, you've got developers who are all involved in various stages of this life cycle or workflow. And various integrations or interactions are required between these users as we go through this iterative process. So many a times when organizations are trying to implement this workflow, they face general challenges in the area of accessing data, challenges with general non-standardized tools that are used in this entire workflow process. You have issues around general collaboration between the different types of users. And then finally, general issues around taking the model from experiments into production. So let's take a look at all of those problems one after the other. So why is there a data problem? We have data problems mainly because most customers have data in various places. You could have your sales information in Salesforce, your marketing information in Marketo, for example. You would have your operational information in Hadoop data stores or databases, and then you would have spreadsheets of information where all of this resides. So a typical data scientist faces a lot of problems in just acquiring the data that it needs for their experiments. And a typical problem that's faced by a data engineer is how to bring all of the data to the centralized place. And even when they bring the data to the centralized place, the issue is the data is generally not clean. So a lot of effort is spent in cleaning up the data. Otherwise, you build a model using garbage, the output that you're going to get is garbage as well. So overall, about 80% of the time is just spent in trying to acquire the data, put it in the centralized place, and then try to clean the data up. Most organizations face this problem. Then there are just too many tools and technologies that are available that service the various parts of the workflow. As many of you know, data scientists are generally used to working on open source tools on their desktop. And then when they build the models, they pass it on to many development teams who just would come up with a one-time setup to deploy those models. So typically in an organization, the data science problems is data science solutions handled by a few data scientists and a small team of engineers. But if you look at the overall problem that the organization is trying to solve, there's no way to create a reproducible model where you can take the same experiments that were run, that were created one time, make it reproducible such that you can build models, train models, deploy it in production in an iterative manner. The third general issue that most organizations face is in the area of collaboration. So many a times, data scientists want to share the information around models that they create, data that they have, and things of that nature. At the same time, they would like to use models that were created by other data scientists. But in the absence of a common collaboration platform between all of these users, be it data scientists, data engineers, business analysts, the entire analytical projects that are being put through these workflows could be at risk. And finally, there's no general or a standardized way to take these prototypes into production. As I mentioned before, data scientists tend to run their workloads on open source on their desktops. And generally, when you're trying to train models, it is very difficult to train models that require resources beyond the scope of a desktop that the data scientist is trying to use. Then, again, you have issues around once you conduct the experiments, where do you store the results of those experiments? How do you compare the result of one experiment to the other? Once you take build a model, put it into production, now you have issues around how do you track the performance of those models? Because over time, you'll get new label data. You want to take that label data and apply it to your model, train them again such that the performance of the model stays up to date. So with data science experience, which is a product developed by IBM, we tend to solve all of these problems that most organizations face. It solves the various steps of the workflow, and it addresses issues around collecting data, analyzing data, transforming data, building models, deploying models, as well as has solutions around monitoring performance of those models in an iterative manner. Data science experience is self-contained, but it's also extensible. It's self-contained because it contains all the tools necessary to develop your models. And it's extensible because it includes Spark to run your workloads. You can also connect to a remote Spark using Livy. It connects to multiple data sources. It can connect to a Hadoop data source and things of that nature. It comes along with a machine learning framework. It comes along with projects that a data scientist can use to bring together data sets, collaborators, as well as notebooks together to be used for a particular task. Now, data science experience has multiple flavors. You have the cloud version, which allows you to run analytics workloads in the cloud. You have data science experience local that allows you to run your analytics workloads behind the firewall on your private cloud. And third, we have data science experience desktop, which allows data scientists to code on their desktop, but also has the flexibility to take the code that they wrote on their desktop and sync it with data science experience local at any time. Now, with the integration of data science experience in Hadoop, now we have the flexibility of leveraging the data that's stored in Hadoop in a very secure manner and allows you to run analytics closer to where the data actually resides. So going forward, so think about data science experience as a framework for data scientists who love to do work in open source, love to collaborate, and want one place to access all of the data and the tools. So with data science experience, you get a rich set of community where you can go and get articles and public data sets that are available, that are generally available to help you learn and explore more in the area of data science. It has all of the open source tools in one place. It has tools like Juypter, RStudio, that allows you to code in Python, Scala, R, and allows you to build models and visualizations using tools like Shiny. In addition, we've built our own value-added capabilities on top of all of the open source that is available. We provide model management capabilities out of the box. We have, as I mentioned before, we also have the performance monitoring capabilities that are built as part of the product as well. And finally, as I mentioned, we have integration with Hadoop. And so with that integration, we can leverage the Spark that's included with Hadoop and run our workloads as part of the Spark that's included there. So finally, I want to just end it here before I pass this on to Vinay for a demo. Overall, with the integration that we have between data science experience and the Hadoop data platform, we have provided the ability to run data science and machine learning workloads at scale. So with that, I'm going to pass it on to Vinay, and he's going to actually show us a demo of how these two technologies work together.
So folks, talk is easy. Walking that talk, that's where the challenge is. So let's try to walk that talk. And so I've logged into this data science experience, and I'll walk through a demo scenario. So what is my demo scenario? So let's pretend I work as a trucking company. Maybe I look like a trucker. But the demo scenario is the trucks have been fitted with sensors. They are collecting the data. And the business wants to reduce the number of violations, traffic violations that happen, because the business wants to reduce the costs, increase their efficiency and time. That's the scenario. So how do we go about helping the business? Because the trucks have been collecting this data for a while at the data center where we have our Hadoop platform and data science experience running. We have collected a bunch of historical data. The idea is, using that historical data, can we create a model that then we can use for the new incoming data as the sensors give us new data as the trucks go around the country? Can we use that new model to predict, perhaps if we predict maybe 10 minutes before a violation will happen? It's like Minority Report, except it's less pre-crime. So then we can alert the driver, say, hey, watch out. We think there might be some violation happening. So that's what the business wants to do. So how did we achieve this scenario? So as a data scientist, I will use DSX. I'll connect to my Hadoop cluster over Knox, and I don't have to deal with Kerberos or anything like that. I'll go find the right data sets. I will do some data wrangling. I'll create once my data is cleaned up, et cetera, then I'll try to train my model. Once my model is trained, I'll try to deploy the model. Once the model is deployed, I'll have the REST API. I'll make sure that REST API is working. I'll test that. Then perhaps I want to integrate that with NiFi. And in case you are not familiar with NiFi, it's one of Hortonworks projects. In Apache project, it's for managing your data flow. So I'll create a NiFi extension and call the REST API over the model that I have just deployed. And the idea is maybe with NiFi, I can kick off a workflow, some other workflow where for drivers who are going to commit violation, perhaps we can send an SMS or some other, or maybe create a dashboard for the managers to look at. So that's sort of like the workflow. The admins will play the role of like looking at the model performance, managing the cluster, et cetera. The data scientists obviously will be the spearhead part of this workflow, and business users will just consume the insights. So that's sort of like the demo scenario. Let's go through it. So I'm running a Python sort of example here. I'm running it with Juypter. But data science experience also offer you choices in other notebooks. And after we run through Juypter, we'll take a look at other examples. So as I walk through the use case here, so here you'll see I'm sort of like trying to create a Spark cluster, Spark session, looking at some data sets. So let's look at that data sets. I'm reading some data. You'll have to clarify the question. What part? So I don't want to get bogged down in there. Let's hold on, because I think the question could be, is the model training or model performance, model scoring batch or real time? So you didn't ask that question, so I don't really know where you'll be going. So let's hold off to that question once we go through it. There will be a time for Q&A as well. So I'm looking at the data that's there. Then I'll do some more data wrangling. Hopefully you can see in the back. Should I increase the font? OK. So then I'll do some data wrangling. I'll manipulate the columns to. Can you
talk us through what's going on?
Sure. So if you remember the slide where we talked about 4 stages of data science, the first stage is problem statement. So you should, if you're doing a data science, as a data scientist, you should have some thesis about what the data is telling you. Again, the thesis will be proven or disproven by data, but you should have a starting thesis. So perhaps my starting thesis for this violation is that maybe if a driver has been weaving in and out of traffic for a while, and maybe if the driver is tired, he's been driving too much, maybe the weather is foggy, perhaps that's where the violations are more likely to happen. That's my thesis. And you just need to know the domain a little bit to come up with a thesis. So that's sort of like the mindset before you actually start writing the code. That's something that should go in your mind before you come down to a notebook. Then
Driven by both the data that you already have and the data that's coming in. What's the delay between going in?
Sometimes the problem starts with a question, and then people have to go and locate the data and try to identify the features or the data sets that you want to use. So if you look at the full picture, it's not like the data is there in the format you need it. So data wrangling is actually the step that tries to bring together all the data in the form that you want. So frequently it's about you start with the problem, then find the data.
yeah, let's hold off to any questions further. I want to make sure we get through the demo, because some of the questions might be answered by the demos, and also we want to make sure we get through the demos, and we'll take all the questions.
Can you also repeat the questions when you're asked, please?
Yeah. So now I've loaded the data. I'm reading the data. And before, as you know, machine learning model training does not work on textual data. The models need to be, the data needs to be cleaned up, converted into some numbers that the model can be trained on. So I'll be doing the steps for sort of, that's called generally data wrangling. And data wrangling is not a new thing. It's been going on in the industry for decades. So here I'm transforming the model. So in the data that I have, the data shows, and if you walk through here, this is my data, that raw data. So the first column is historical data. Was there a departure, lane departure or not? So these are like, this is a normal event. The other things are, there was a lane departure. And then the columns here don't mean much to me. Then this miles column is about how the driver is being paid, miles per driven. Then you don't know what column that is. This looks like lot and lang, but you have to understand that data well. So that's where now, because I understand that data, I'm going to put some column types on it so I can read that instead of C1 and C2. So that's stuff like that. So now I'm doing that. The one thing I'm also interested in, so in this prediction, the traffic violation can be of multiple types. For example, if somebody is tailgating or speeding or sort of not maintaining safe distance, these are all traffic violations. But for my purpose of demo, I'm not interested in individual subtypes of traffic violation. I just want to know whether it's a traffic violation, yes or no. So for me, it's a binary. So because my data is not like that, I'll have to sort of convert that into a binary class that I'll further use. So for that, I have defined what's called Spark UDF, a user-defined function. So I have that Spark UDF. So next, what I'll do is, here I have defined the UDF, and I'll run the UDF. So now you can see the the data sets that I have. So you see the event type. This has become a binary class, whether there was a violation, yes or no. And the columns have some meaningful names. So you can now start to sort of understand it a little more intuitively. We can also register that as a temp table. So if you are familiar with Spark, you know what's going on. I'm just calling Spark via the Python API and doing some data wrangling, data cleaning, nothing earth-shattering. So there, I've done a lot more analysis, and my colleague Dhananjay here has created a lot of beautiful visualization. For the purpose of the demo, I'll just show you these visualization, because when you try to run them, they take too much time, and that's not the main part. So you'll see there are lots of visualization that are possible. You can create them. So so you're using Seaborn library here. You can create a lot of visualizations. And here, that's where you have to be intuitive about data. So as a data scientist, before you start training the model, you have to have some thesis. And then based on the visualization, based on how well you play with the data, you'll maybe prove or disprove some of those theses, form some new thesis. And so, for example, one of the theses could be, for example, some drivers could have taken driver safety courses. So perhaps the thesis is maybe certified drivers have less violation. So you can sort of use some data analysis to prove or disprove all these theories. So I just, because I wanted to jump to machine learning and training the model, I'm not interested in analyzing these theses. But the reason I'm showing is that with data science experience, all this is possible. So there are lots of different types of things. So now we are going to build a machine learning model. So what do we need to build a machine learning model? Well, we first need to have the data cleaned and ready. Then we have to know what type of problems, what type of predictions are we trying to make? Are we going to classify something? Are we going to predict a continuous value? So we have to know all these things in advance. So for the purpose today, I'm going to use a random forest classifier. And so I'll invoke, make some imports there. And I'll be leveraging the Spark ML, which is the pipeline API. So for that, I'll get some string indexer, which if you have some textual labels in the columns. So for example, if you have, let's say, if not in this data, but let's say if you have a data where people's home state was listed, and perhaps that's categories. And then based on maybe the audience, if we were to create a home state of everyone here, maybe we can create a string indexer which will have the home state in the order of the frequency of the home state for different people. So that's what string indexer is doing. It's ordering some categories, converting them into a numerical number in the frequency order. So I'm creating some string indexer. Then I'm creating a vector assembler, which is basically taking the string indexers and using those numbers there, creating a vector a representation of all the input there. So I did that. So once I have that, I create a random forest classifier. I create the Spark's pipeline API and pass to it the string indexer, vector assembler, et cetera. So I did that. Now the data set I have, I split that into training and test data sets and in the 80-20 ratio. And the idea is I will train the model or fit the model on the training data sets and then test the model's fit on the test data sets. So that's that. Spark provides the ability to cache the data frame, so I'm caching that to speed up. So do that. So now we can see what's in the training data frame. This is where pipeline.fit. This is where I'm invoking the API, Spark's ML API. And this is going to take a few seconds. Actually, the data set here is not very big. That's not the main point so far. So then the model is trained here. Now we'll try that running that model against the test data sets. So then we do result.shows to show how the model did against the test data sets. So it's somewhat reasonable. let's see, I'll convert it to pandas data frame and show the first 5 predictions. That's all right. Then I'll do some model evaluation, and I'll use the compute the AUC or area under ROC curve. So for those data scientists that are really, that know what's going on, you'll see 68%, you should go back and restart. But for the demo, I'll say, all right, it's good enough for the demo. But realistically, anything below like 90%, like why bother? So then I'll use the API DSX provides, which is to save the model in a repository somewhere. So I'm invoking the API, then creating an ML repository client. This is just typing the model type. So now I'll invoke the API to save the model in the ML repository. So this takes a little while. The model is sent to where the model repository is. This is also a feature of DSX. So once the model is saved, I'll invoke some, I'll print various properties of the model, where the model is stored, what is the version of the model, what is the REST API, where the API or the model is available. So you can make all these prints. So once the model is saved, there is a step in DSX to actually take a saved model and call deploy on it. So now I've already deployed, saved the model and deployed the model previously. So once the model is tested, or rather saved, there is a UI available within DSX where, and this is the screenshot of the UI. I'm showing it inline here, but I'll go to the test page as well, and we can see this test page live. So here in this screenshot, you see in the model, you can pass in various inputs, whatever longitude, latitude, whether it's foggy or not, and based on that, it will make some predictions whether this is going to be a violating event or not. So that's sort of like what the test API looks like. The model, as I mentioned, is also available over REST API, and for our demo purpose, we want to make use of the REST API. So here, I'll get an access token. So I'm making this call to get the bearer token for the model. So model is protected. Don't look at my user ID and password. Now I'll make use of, then this is the model invocation. So here, this is a screenshot. I'll do it, show you live. So here you'll see that once you have the model's REST API, which is the HTTP blah, blah, blah scoring, you're calling the REST scoring online. So that's the API and passing in your test data, and that's the rest of the data. So here, if I switch to my console, to Control L, so you can see I'm now invoking the REST API. It came back, and it says N here. Based on the input N, I know in this model means it's not going to be a violating event based on the input. So that's sort of like the REST API. So now I think, OK, maybe my model is at least available from a REST endpoint somewhere else. What else can I do with it? I promise you NiFi. So let's go see what we can do with the NiFi. So here's the NiFi flow. Those of you, this is not a NiFi session, so I'm not going to spend much time introducing NiFi. But essentially, NiFi allows you to visually create a data workflow. It has the concept of processors. You can read data from various sources. You can send data to various sources. But this is not a NiFi demo, so we'll not spend much time on it again beyond this. So here, I've already created this workflow, or actually, my colleague has created the workflow. I'm just the dummy running it here. So in this execute script, you can see if you look at the configuration of the execute script, and you see the properties, I always have trouble with the scroll here, or maximizing this. So you can see there is the method call, or there is some code written in there, and then this NiFi processor is actually calling the same REST API that we ran from the command line. So it's the same REST API call. So the NiFi processor is coming there. So the idea for this NiFi workflow is that we have simulated some data. So that's the simulate data box there. Then we are using the simulated data. We are calling the REST API for model prediction. And we are saying, here's my simulated data. Tell me what is your prediction. Then based on the prediction that's coming back from the REST endpoint, we know whether there will be a violation for a given data set or not. And then the rest of the workflow basically splits the data into two different streams. One, all the violating events, and the other non-violating events. So hopefully, then the violating events could be sent, could be that there is an SMS process handling the violating events, or maybe we can create a report for the managers to see when they come into work next day. So that's sort of like what we do with NiFi here. So let's look at what data we have seen. So we can see the data provenance. So I ran this workflow like a couple of hours ago. So you can see, let's see. So for this model, you can see there was an access token sent. This was the prediction. Prediction label is yes, this is a violating event, so maybe I should do something about it. So that's sort of like invoking the REST endpoint from there. So today, right now, I'm not doing anything. I'm just putting all the violating events in a put file. But in a real life scenario, this is your chance to maybe send an SMS or email to the driver. Hopefully not email to the driver. You'll be causing more violations. SMS too as well. So maybe there is a different way. Yes, sir.
So far, could you please highlight what is your advantage or other? I mean, this seems like a regular batch process that you run against and create a model. What is the advantage of using the approach that you just provided from the beginning?
What's the advantage of what? NiFi or?
Well, I could have done the exact same thing using, say, an account.
All right. So that's a big question, and I'll take that question. So the question is, what's the advantage of DSX? So I don't know when you came in, if you saw the initial part of Josefa's talk. So the whole point of data science experience it's all built on top of open source technology. So if you know your way around open source technology and you're willing to take all those pains, you can stitch everything together, deal with the pain yourself. Or if you want an environment which not only brings the tools together, but also provides for model deployment, model management, and monitoring, that's something where DSX adds value. Now, does it have some overlap with some other pieces? Of course it does. But there are a lot of other features of DSX where there is no overlap. So
So is the bundling, is the fact that you bundle all these technologies in one environment is what stand out.
Yeah, and plus it allows you to collaborate once you
there is also collaboration, and we'll walk through it. So that's why, let's hold on to that question because we are not finished with the demo yet. So more things may probably stand out. So now we saw that how we do end-to-end model deployment, but my manager tells me that I need to work with somebody else. I like working alone, but my manager tells me I should be working with somebody else. So let's keep my manager happy because it might be time for bonuses soon. So now this was the project I was working on, demo project. I see I have 3 collaborators. And let's see if I can add some more collaborators. So I can add Dhananjay, and I want to give him maybe the viewer role because he only created this demo, but he owns the demo, but I just want to give him the viewer role. So then I log out, log back in. So any typo I make on this screen is not because I type poorly, it's the name is also hard. Oh, wow, no typos. So now we can log into this as another user. He can see the project. He can see the assets. But as a viewer, he can see the deployed model. And he can see the notebooks. So this shows the collaboration aspect of it. So while this is launching, let me switch to another console. Because DSX not only allows you the ability to use Juypter, but it also allows you to use Zeppelin, RStudio, and other notebooks of choices. So let's pretend I'm now a business analyst, and I'm looking at the same data sets, but I'm not trying to create a model. I'm just trying to run some SQL-type analytics on that data and perhaps get some more insight out of it. So I have a Spark job that I'm going to launch. And this is going to connect to the HTTP cluster, read the Spark data, So this job will launch. It will take a few seconds. If anyone has launched a Spark job against a running Hadoop cluster, you know the first time when you create a Spark context against a running cluster, that takes a few seconds. So then while that is spinning up, you can see I've ran it earlier in the day. And here, so one advantage of Zeppelin over any other notebook is in the same notebook, in the same sort of page, if you imagine, you're allowed to mix different languages. So my first paragraph is just the Spark's Scala API. The next paragraph is obviously SQL. So in the same notebook, I'm mixing different paragraphs of different languages. So I'm doing that. So here, I'm running just, so what I'm doing here is basically reading some data, creating some case classes, and converting that into RDD. And once I have the RDD, I'm registering it, connecting it to a data frame with 2df method. Then I'm registering a temp table. And temp table basically register that thing as in the Spark's default Derby database. Or if this is wired against Hive, it will store that in the Hive metastore. And it allows you to now query that table from another paragraph. So now I'm making use of this temp table as if it was a regular table, and I'm running query against this. And wait a minute, what is this warning here? Previous Livy session expired, all that. So if you have used Livy and Spark and Zeppelin together in the past, you know Livy session was kept alive, but it used the cluster resources. So we have started expiring the sessions underneath. Not only we expire the sessions underneath for convenience, when you try to do a new job, a new session is automatically created and attached to your running notebook. And that's just optimization. So in a multi-user environment, your cluster runs more optimally. So now we can go take a look at this Spark's web UI. And you'll see that it launches Spark job. So you can, if you're familiar with the Spark, this is just the Spark history server UI. You can see the job is running. And as we run some more SQL commands, you'll see that job gets busier and more data will flow to the history server. So I'm now analyzing it using SQL. I can do some more analysis using Livy or Spark and Livy. So you can run that. So I've run it a few more paragraphs here. Now if I go back to this, you can see this will have a lot more statements because each statement resulted in further Spark jobs, et cetera, all tied to the Spark history server. So you saw now that I was able to work as a data scientist. I was able to create a model. I was able to do some data wrangling. I was able to, as a business analyst, run some SQL statement, use a different notebook. I was able to even deploy a model, invoke the model from some other places. What else can I do? So we go to the community landing page. We can see what other notebooks are there. So perhaps I'm a new member on the team. Maybe I can find a data set or a notebook that somebody else has written. I can learn from some that notebook and get started. I can also see the deployed model that have been there. So, so we can see the models that I've been using is the model prediction here that's been deployed. So there is a lot I can do here. But let me try to summarize sort of what we saw. So we saw as a demo scenario that as a data scientist, I can collaborate, learn new tools and frameworks. I have a choice of notebooks. I have choice of languages. In this demo, we use Python, Scala, and R, or rather SQL, no R today. I can use whatever favorite notebook I have and run it against all the compute and data that you have in your cluster. I can deploy the model to production. We can deliver the predictions coming out of that model over REST if you want to do online scoring, or there is also the REST or batch way to get a lot of scoring out of your model. And for the last part, I wanted to switch my laptop because I didn't have, in this environment, model prediction or model performance. So I'll have Vikram come on board and show you the last point here.
Hello, everyone. How are you doing? Tired? Trust me, you'll like it. So Vinay showed a really nice demo, and I just wanted to tie it in with some of the key aspects of data science experience. But before I jump into the demo, I wanted to show you, our roadmap. So what are we doing with Hortonworks? So IBM announced the partnership with Hortonworks back in June during the Hadoop Summit here. And since then, we've been very busy working with our partners at Hortonworks. And we decided to come up with a three-phased approach. And the three-phased approach was, at that time, you could install DSX on the side of HTTP cluster, and we could connect to a HTTP cluster and work. But there was no deep integration. We could connect only to a non-secure HTTP cluster. We couldn't authenticate using Knox. So it was really not much helpful for Hortonworks customers. So since then, we worked very closely with, both engineering teams have worked very closely. And we've introduced data science experience. In fact, we went general availability today with certification for Hortonworks HTTP 2.5.6 as well as 2.6.2. And very soon, when 2.6.3 comes out, we'll be certified for that as well. And as part of this, what we're doing is, so today you can still install side by side, both clusters, but we can authenticate using secure Knox. Okay, we can authenticate to a Hortonworks cluster, HTTP cluster using secure Knox. And as Vinay showed, you can use Spark. So DSX comes with its own inbuilt Spark. But not only that, you can actually use the Spark which comes with HTTP, and you can choose to use which Spark you want. So for smaller, test cases, as there are some data scientists here, you want to do some data wrangling with smaller few MB of file, you can use our local Spark. But for larger, the Spark which comes with HTTP is very well, managed and resource balanced, and you can use that Spark as well. So all that is possible. But the next phase is going to be where you're going to see deeper integration. And what I mean by that is we will be an Ambari management pack. You'll use Ambari for bringing DSX up, provisioning DSX, and so on, and for management. And the third phase is going to be where we're going to work, again, very closely with Hortonworks and come up with Yarn as the resource manager. So data science experience uses Kubernetes. It's a Kubernetes orchestrated, we use Docker containers. And we use Kubernetes to orchestrate those Docker containers. And in the third phase, we will also be using Yarn as the resource management. It is best in class, does resource management really well. So imagine you running a machine learning or a deep learning workload on top of 500, 600 HTTP clusters that you already have, and Yarn is going to do the resource management for you. So really nice roadmap. I have one more screen here. It's, well, I'm going to skip that and go directly to the demo. I was going to show you the roadmap, but I have some issues there. So this version of data science experience that you're seeing, this actually GA'd, GA being general availability today. So it's 2 days newer than what Vinay showed. So as soon as you log into data science experience, and I think there was a question at the back sometime back, and you're asking, there are a lot of open source things here, right? So why do I need DSX? Yes, you can go be the integrator. You can download most of these off the internet, and you can aggregate them and you can use them. But I was working with an enterprise company, an insurance company, about a couple months back. They have 10 data scientists working on data science for about 2.5 years, and they don't have a single model deployed in production. Okay, and we asked why. You have 10 people, you're paying them for 2.5 years, and why haven't you operationalized your models? And they told me, well, these data scientists, they download a bunch of open source. We have no idea where they download it from, what the security protocols are, if they are, if we can distribute them to our clients within the insurance industry, nor if we can put our personal information, PII data, our customers' data on these open source tools. And they wanted basically one vendor to choke, right? So that's where they turned to IBM, and today, just in 2 months, they have deployed it in production and they are up and running. So it's not about just open source. So IBM is fully committed to open source along with Hortonworks, but it's about how you package it and how you govern it, how we can use our auditing capabilities and scale it at an enterprise level. So that's what we are looking at. Okay, so when you log into Data Science Experience, you have this sample notebooks here, and Vinay actually showed them. These sample notebooks are not just for beginners, it's for everyone. So you might be working in one specific industry. You might want to see what a data scientist in another industry has done, how he's using data wrangling techniques, how he's using his skill set with Python or R or Scala. And we have about 60, 65 notebooks here. You can click on more here, and that will actually take you to our entire list of notebooks. And we are adding more. Okay, and those are all sample notebooks, yes. And you can actually click on a sample notebook. You can download the sample notebook, and you can start changing that or editing it or run it directly. These sample notebooks have data inbuilt. So again, we don't want to be distributing data which we don't own. So we have come up with data sets which are inbuilt, and you can actually run these off the cluster itself. And we are adding more. And in the next versions of Data Science Experience, especially for enterprises, we are coming up with a mechanism where you can publish your own. We are working with some, again, as I said, insurance companies, with some banks which have 100, 200 data scientists. There are areas within a bank which might create a particular notebook that they want other data scientists within the bank to use. So we are coming up with a publishing mechanism where this won't be a static IBM provided notebook sample, but data scientists within the company can publish to that location as well. And then we have projects, and at the bottom we have helpful links. So what projects is think of it as a personal workspace. So when you log in, you go create a new project, and once you create a project, it starts off as a personal workspace, and that's where you go create notebooks, be it Juypter or Zeppelin, or if you want to use RStudio, you want to create models, you do everything in there. And then when it is time to share that work with another data scientist or a data analyst or a business analyst or a data engineer, you can actually do that. So I'm going to quickly show you how projects look. So I have a few projects here. I'm just going to go into one of my projects here. And here, this project, I've already created some notebooks, and these are all Juypter notebooks. But adding a notebook is as simple as, either from file, or I can select a URL. For Juypter, you have to pre-select Python, Scala, or R. But as Vinay mentioned, for Zeppelin, you have the added advantage of you don't have to select a specific language. You can create a Zeppelin notebook. You can go inside the notebook and start using different languages. So once you have a notebook, collaboration is super easy. I can go to view all collaborators. I can add a collaborator. I see 2 more people on this cluster. I can select a viewer, editor, or admin and make them a collaborator that easy. Okay, and now they are a collaborator. So it becomes very easy collaborating with other people, right? And those of who you are, data scientists, if you work in siloed environments, one of the most important or difficult tasks is how do I show my work with a colleague? When you work in silos, it's okay, it's perfect. But when you work as a team, it's difficult to share information, and that's where we come in handy. Yes?
So is the collaboration more of a Google Doc collaboration, or is it more of a GitHub collaboration?
Actually, that's a very good question. So the question for people on the phone and on the video is a collaboration a Google Doc kind of collaboration, or is more of a GitHub kind of collaboration? It's actually GitHub. So all of our projects, all of the assets are Gitted. They are Git tagged, and we use GitHub under the covers. So you have versioning, through GitHub. Collaboration itself is actually, we have a user management console here, and I'll actually show it to you. Well, I don't have admin privileges, so I can't. But we have a user management console here where you can actually go in and add additional users to your data science experience cluster as an admin. And when I previously was here and I showed you how my collaboration looks, when I add additional collaborators, so these are all users on this particular cluster added by an admin. And once they are added to this cluster by an admin, I can see who they are, and then I can pick and choose if I want to add them or not. But as far as versioning goes, we definitely do use GitHub, and that really helps us with version control. It helps us with promoting code from one environment to another. It becomes a lot more easy. And in fact, the first thing when you do, when you come in and you create a project, a new project, is you can either create it from a blank project or from a file. The file is really interesting because we have introduced a concept where you can export. So imagine you have a project, which is your personal workspace. You created like 30 notebooks. So now how do you move these notebooks from one environment to another? Previously, you had to save each one of them and then move them. Or if you have root access to your file system, you can copy those files and put them somewhere else. So now you can right-click on a project, export it as a tar.gz or a zip, take it to a new environment, just import it, and you have all your assets just preserved. And the third way of creating a project is GitHub, GitHub or GitHub Enterprise. So we support both of them.
So just one thing to add is that we use Git under the covers. So even if you don't use GitHub, we still version. Sorry. So we use Git under the covers. I mean, if you're familiar with Zeppelin and other tools, they use Git already, right? So we do versioning, we do tagging. You'll see that you can commit and share and accept other people's changes. That's kind of like business as usual. GitHub and GitHub Enterprise is how you can actually work with an external server-based Git repository.
Yeah, thank you.
Export and load the project onto GitHub account?
Sorry, could you repeat that?
So like how you enable importing from a GitHub repository, is it also possible to export this project onto a GitHub account?
In a way, yes. The question was whether you can export and import with GitHub. But what we really do is we do a Git pull and Git push. So we just use the Git mechanisms. But there are other ways of doing it. Like for example, what Vikram mentioned was export it and then yeah, you can also do that.
Right. So as part of projects, we've also included RStudio, and then we have a model section. And this was something that Vinay was showing. So we have APIs. We have training APIs, coding and deployment APIs. And we expose all these APIs. They're all documented. So you can use them from within a notebook framework. And you can call these APIs, and those models will actually be stored here. And with a single click, you can actually push this model. You can deploy this model. And this publish model, Josefa mentioned that we have 3 versions of DSX, right? You have one for the cloud, one for on-prem, which is DSX local, and the other one is your desktop. We actually can just click publish model, and we can push this to Watson ML. So someone here earlier was asking me about Watson Machine Learning. So Watson Machine Learning is the name of the product for machine learning that we have on the cloud. And if I know my cloud credentials here, I can just give my credentials here. So now you've created a model locally within your, behind your premises, behind your firewall, on-prem, and now you can push it to cloud as well. Yes?
So, how portable is the model once you create it? Now you just show, you can export to Watson.
Mm-hmm.
How about exporting to other platforms like RStudio or other development platforms?
Actually, that's a very good question. So the question was how portable is the model? Can I move it to other platforms, right? And one of the examples that you asked was H2O. In fact, with today's GA, we are GAing H2O, or I shouldn't say GA, we are having H2O as a beta. I don't have H2O on this box, so I can't show it to you. But our beta products are usually add-ons. So you can request an add-on. We will give it to you as an add-on, which you can install. And H2O is another IDE environment. We have H2O libraries installed. So it's another IDE environment that you can use to as for notebooks or train models, deploy, and so on. So these models, if you create Spark models, yes, you can export them. As far as the version of the Spark is the same way you trained it, so you can export it. And what I showed you with the publish is technically that. So I'm creating a Spark model here on a specific version of Spark. And when I publish it to my cloud, it's a completely different environment of DSX there. It's a completely different install. It's actually not even the same code. It's a completely different code. But now you're technically just taking that model asset, you're pushing it to cloud, and from my DSX environment there, I'm scoring and deploying it. So as far as your Spark version is the same, you're fine. Now, Spark is just one aspect of machine learning, right? It's just one analytic engine. We have XGBoost, we have TensorFlow, we have scikit-learn. So as and when these frameworks come into the picture, as far as your training using a specific framework, and you're using a set of libraries to train that model, no matter where you take those models, as far as you have those libraries and you have the same version of Python there, you're fine. You're not restricted, and that's why I say DSX is actually built on open source. Our goal here is not to lock you within our framework. Our goal is to give you a choice of tools, and you choose what you want to use. Sorry, there was another question there. Yes.
User of IDEs SPSS for building models. So do I see this as a transition from SPSS into the
That's a very good question, and I see my product management colleague here smiling. Yes, so what we are doing right now is, if you look at my models here, I can go add a model, and I will quickly show you SPSS has something called SPSS Modeler. And SPSS Modeler is a drag and drop, it's a canvas style flow. Flows is another thing, as I was mentioning, is an add-on that we can give on top of data science experience. It is still in beta, but we have our teams working on refreshing SPSS and taking it to the market on top of DSX. So if you are an SPSS customer, you will be able to bring those flows into DSX. And right now, I have, like when I add a model, I can choose from file, and I can choose the model type here as PMML. And SPSS modeler can actually output files as PMML, or the proprietary format that SPSS modeler outputs files is .str. You can actually bring .str files. If I had the flows add-on in here, I can bring my str files and I can use it. I don't know, Zephyr, if you want to add something.
The only thing that I'd mention is the SPSS modeler is mainly built around providing capabilities to a non-coder. So all the non-coding capabilities you'll find in SPSS modeler. DSX is mainly designed to provide all capabilities for a coder. Even though we're looking at adding capabilities like flow that will bring in non-coding capabilities. But if you're used to using SPSS, continue using that, because there's changes that we are making, investments that we're making in SPSS.
Yeah. So the idea is that I mean, if you're used to SPSS, it's a product that we've had for so many decades, right? So there are a lot of investments going on into that product where we are refreshing it, and that stream is going to exist. But data science experience as a platform, so think of it as just because you use SPSS modeler, your work is not gone to waste. You can actually bring that work in here. And I'll show model management, and this is what Vinay called me up here for, and I've been talking about a lot of other things. But model management, think of it as one single pane of glass, right? Where no matter where you created your models, you can actually maintain and manage them from here, administer them from here. So SPSS is one good example, and there are other proprietary tools in the market that you can use to create models. Our goal is that, especially if it's PMML format, you can export that model, bring it in here, and you can deploy in here. And this is one of the things that we always hear from customers, is that they have so many different tools, open source, proprietary, between different companies. So how do I manage all these models in one place, right? They have so many different management dashboards that either they have built or they have inherited from other companies, and they are finding it very difficult to manage and maintain all these models. So with our model management dashboard, you can do all of that from this one single pane of glass, right? So be it SPSS or open source, you can actually maintain and manage it from here. So when you land into the model management dashboard, at a very high level, there is a graph here that shows you the model performance. What is the health of the model? And we have recent deployments, API calls, and so on. But let me show you models. So this is an actual model. If I can get to that screen. There you go. So I have created some models here. And as I previously mentioned, I can right-click on this model and just deploy, right? And that will go into this deployment section. So let me click on deployments. I already have a few models deployed here. The whole thing about operationalizing a model, getting the data, cleaning up that data, picking the right classifier to create a model, creating a model is just one small aspect of model creation. The actual, where the rubber meets the road is when you score and you deploy that model, and then an application developer is actually able to come in and use that scoring endpoint of that model, right? That's where the ROI is. So if I go into one of these deployed models, you will actually see the scoring endpoint. So this is a scoring endpoint. And in the previous example, what Vinay showed in his cluster was from the curl command as well as the Spark history dashboard. He was actually, his notebook was actually calling this model, or whatever application he created was actually calling one of these models using that REST endpoint. So this endpoint, scoring endpoint, is the single crucial thing in a model lifecycle, right from ingesting the data to picking a classifier, training a model, scoring a model, deploying it. But an application developer really needs to use the scoring endpoint to be able to call that model and use that model. So that's when it really becomes operational.
So the REST API is automatically provided by the DSX?
Yes. So when we deploy a model, and I will show you really quick a model deployment. I showed you a list of models that I had. When I right click on it, all these are published models. So these are all my published, my saved models. When I go click on deploy, I select my type. I'm going to say online. My engine is already selected because the model was a Spark, created on a Spark ML. And this model is deployed right here. I just deployed this model. And if I click on it, it will already have a endpoint. That's my endpoint.
So one thing to add, you saw earlier about our about Vikram's slide where he's talking about full integration and workloads being managed in the Hadoop cluster. One of the workloads that will be managed is this scorer, right? So what happens is when you imagine you have a very important model, it takes a while for the model to be loaded and to run the prediction and to get a response back. So what we are looking at are scenarios that you'll see in a few months' time, where as a deployer you can identify that this is a model that must be preloaded in memory. It might be a 2 gig model, and you need 2 gigs or 4 gigs of memory to preload it. And it's a very popular model. I have a lot of applications hitting it. So I'm going to start up 4 copies of that model scorer, exclusively 4 copies of it. So now DSX will automatically load balance it. And even if you have many applications hitting it, you'll be able to handle the load. And then you find that it's very popular. Like based on the API calls, you find that a model is very popular or more popular than you expected. So you just scale it up. You say, oh, I want to have 2 more copies of the scorer running only for that particular model. So those are the kind of enterprise capabilities that we are looking to deliver on in DSX and on top of Yarn.
Yeah, and part of that, so we've introduced something called runtimes, and runtimes is something we first introduced in early September, and we've since built on it. So right now, I have RStudio, Zeppelin, and Juypter. So to what Sriram was saying is that where we want to take this, so I can click on one of these runtimes. So right now, this runtime by default is supposed to use only 1 CPU. So if this Juypter or Zeppelin runtime, this is a Zeppelin runtime, I know it's very important for that particular user, and he's running some hypothesis or some analysis. And if I want him to use more CPUs from the available list of CPUs, I can just slide the CPUs here. And I can say I want this guy to use 4 CPUs. And then by default, this runtime can use only 2 GB of RAM. But if I want to increase it, I can make it 4 GB of RAM, right? And I can say save and start, and that will actually save and start that pod, that particular image, with ability to use that much CPU and that much RAM. And as Sriram mentioned, the idea is that based on the number of API calls that you saw in my model management dashboard, I can actually pick and choose which models. If a model is being called 10,000 times and then there's another model being called only 10, 15 times, then I know the model that's being called 10,000 times needs more resources, so I can easily allocate those resources. So yeah.
So how are you serving the models? Model server or Hadoop or Spark cluster?
So the question was that how are we serving the models, right? So currently we have a model server inbuilt in DSX, and it's shared in common with Watson Machine Learning as a Service in the cloud. We are extending it to make it a little bit more heterogeneous and scalable. So for example, it needs to serve different types of model and also to provide scalability and high availability, like I mentioned before. So that's where we're spending a lot of effort.
Yep. Okay, another question?
Two questions. Is this only for IBM cloud, or it's also from other public cloud, AWS?
Actually, that's a very good question. So the question,
The second question
okay.
is this a free product or is it a commercial product?
So I'll answer both questions. So the first question was, is this a product only for the IBM cloud, or does it work on other clouds? So this product is actually an on-prem product. It's a data science experience local. It installs on-premises, which means you bring the servers, and it's behind your firewall. So now, you can install this product. If you go to AWS and you procure your own x86 servers, sure, you can install it there. It's not specific to IBM Cloud, but I would recommend that you use IBM Cloud for obvious reasons. Yeah, so we have this data science experience. We have a cloud version of the product as well. So you don't have to go install it. It's already available to you on the IBM Cloud. But our collaboration with Hortonworks, HDP being an on-prem installation of the product, DSX Local is an on-prem installation of the product you can use with it. To answer your second question was, is the product free? So we have 3 versions of the product. The cloud is one. The second one is Data Science Experience Local. And the third one is Data Science Experience Desktop. Now, the desktop does not have a lot of enterprise capabilities. It still has Juypter notebooks, Zeppelin notebooks, RStudio, and Spark. It's got all the libraries that come as part of Data Science Experience, including the machine learning libraries. So technically, from a notebook interface, you can create models, and you can save those models, but you cannot score or deploy them. And you don't have enterprise capabilities like collaboration, any of the governance capabilities or versioning. You don't have any of those. So we are working on Data Science Experience Desktop. Imagine you're on a 10-hour flight ride, and you don't have access, or your access is not enough to VPN into your network. That's when the desktop comes in very handy. It is a free product. You can install it, and you can do work in it. As soon as you land, with a push of a button, you can push all the work that you did to your cloud or your local instance. So that's how we connect our products. But that's the free version of it. So this is a paid version of the product.
Just a quick question. So
Go ahead.
where does this experience platform fit in the IBM Analytics product portfolio? Because you have all of them. I was looking at one customer experience analytics platform, IBM SPSS. So what category does this fall into in terms of the portfolio you have?
So I think the question is, where does this fall in the IBM portfolio? Where does this product fall in the IBM Analytics portfolio? Right. So if you look at what I'm sharing here, this is the machine learning life cycle, right? You have data sitting somewhere, multiple places or one place. Then you ingest that data. If it's in multiple places, you try to bring it into a repository, a data lake, or a data swamp, whatever you want to call it. And then you do some data wrangling on the data, do some data processing. Then you create a model, and the steps to create a model would be to pick a good classifier, the best classifier, and then you create a model, you train, what we call training, and then you score and deploy that model. So this is the life cycle of machine learning, right? So if you look at IBM Analytics, the products that we have in our analytics, it actually fits in this life cycle. For data, we have IBM databases, and we are partnering with Hortonworks for HDP. So technically, that's where your data will reside. For ingestion, we have IBM tools for ingestion. So think about, for ingest and data processing, there are a bunch of tools. What Vinay showed you is how you can do data wrangling from a notebook itself using Python. Right? So Python is very, very powerful. The notebooks, the IDEs that we bundle as part of DSX are very powerful. Can you use multiple other tools to do it? Yes, sure you can. But from a data scientist perspective, he's not looking for developer kind of tools to perform those activities. You want to do all of these from within that environment itself. And that's what DSX provides to you. But you can use any of these other products, right? So SPSS, for example, IBM's portfolio of data science, we've been doing data science and machine learning for a long time. Maybe we never called it that. SPSS Stats, SPSS Modeler, these are all really good examples. We have another product called decision optimization. And decision optimization, in fact, if I switch over to my notebooks here, my sample notebooks, one notebook caught my eye. There was a notebook, and our decision optimization team is in France. And they have written a sample notebook here which talks about how do I make pasta or something like that. So decision optimization libraries are now part of data science experience. And so it's not about what product you use. You can use whatever product you want for data science, but how do we bring all of them together, right? So that's what data science experience is about. You're welcome. Another question there?
Where do we have resources to learn more about this data science experience?
Good question. So the question is, where do we have resources to learn about data science experience? You can go to datascience.ibm.com. And there we will have, and I can go here. So this is our external landing page, and you have docs here, which is our documents. You click on that. If you want specific to local, which is the product that we are talking about right now, you can click on local here, and they'll give you all the information about data science experience local. But you also have cloud and desktop, and you can look at those as well. There's another question here. Go ahead.
And also the community is actually available from that link as well.
Yes, that's right. Community and blogs. Sorry, go ahead.
So this is about your model monitoring or model management module. Is that dashboard or module or the visual interface user customizable in the sense if I want to add my own metrics or graphs, can I add those there? For example, I want to look at population stability index. So can I run a code and then design a graph and then add it on that dashboard?
So let me repeat the question. So the question is, I show the model management dashboard, and the question is if this dashboard is customizable. Can I add more widgets to it, and specific? Can I add metrics to it specific to my line of business? The answer is no. This is not customizable. But if that is something which customers really want, and we can definitely look into. But at the beginning of my demo, I mentioned something around publishable apps. So if you're familiar with RStudio and RShiny, so you can actually do work in RStudio, and you can publish the work that you did to the Shiny app server, and you can share one URL with your colleagues, your data scientists, your executives, and that those people can just click on that link and they can see the work that you did. So similarly, we are working on a publishing mechanism where you can create your own app, right? And this does not require you to know coding and stuff like that. It's going to be very simple. Just like RShiny, you will be able to create your own app, and you will be able to publish it. And that app is going to have facility for you to include a lot more widgets and dashboarding techniques and so on. So that's going to be our answer. But right here into the model management dashboard, if we have feedback from customers like you, we'll definitely look into it.
So yeah, we did get some similar questions. So it is a little bit difficult. People want to have model visualization and metrics, custom metrics. We do have the tools. We have visualization tools, so you can actually build that yourself because the metrics is actually available within the DSX environment, and you can publish it. Right now, it's not exactly a custom dashboarding tool, but that's something that we've looked at, and we kind of need a little bit more volume and stability in our product for model management, because right now we don't support a lot of model types and frameworks, and we don't do scalability. So we want to get the runtime and resource management right first before we look at other visualizations.
So by the way, when I was showing you the sample notebook in Juypter, he showed a lot of visualization in it. So we include a lot of these visualization libraries within the product, and we have a way by which customers can bring in their own libraries and packages as well. The Anaconda ecosystem is very vibrant. In fact, we bundle Anaconda with DSX. But keeping up with these libraries and packages is very difficult. So customers have that choice of libraries. We allow them to bring that in. So IBM Research actually worked on 2 such libraries. One is Brunel, the other one is Pixie Dust. And both are visualization libraries, and both are open source. So those are included, right within the ecosystem itself. So what we have seen that our data scientists, when they work with other companies, they are using these notebooks ecosystem either in Juypter or Zeppelin, and they are trying to come up with dashboarding style graphs within that ecosystem itself.
So
Go ahead.
one more question. In a
Yep.
local environment, do you have any metrics showing what is the impact of having DSX on the storage or the processing power?
So
not DSX?
The reason I'm smiling, so the question is there a way I can look at my consumption, my server usage, my storage, and so on? And since I had logged in as my persona, I didn't have access to the admin dashboard, which I mentioned previously. So if you go toggle here on the top, you have what we call the IBM Data Platform Manager. And this is the place where you will administer DSX. And here you see the CPU usage, memory, disk usage. We have node level information. At a high level, you want all these to be green. Your nodes are doing fine. And you can click on each one. This is a 9-node cluster that I have. And I can go into each one of these clusters and see how they are performing, what the CPU usage is, what the memory usage is, and so on. Previously, I had mentioned that we are Dockerized, containerized, microservice-based architecture, and we use Kubernetes for container orchestration. So all these are the different pods running on my cluster right now. And we use microservice architecture really well. And what I mean by that is if there is one single pod that we need to update, you don't have to take the entire system down. You can just target and upgrade only for that one pod. Everything else is up and running. So this is the admin dashboard that you can use. We have alerts here. You can look at all the alerts. Kubernetes takes care of HA. It takes care of a lot of resiliency. But you can come here to look at your alerts. We also have user management here. And this is where you would add users. So previously in my projects, I was actually collaborating with a few users. As an admin, this is where I would come and add my users. Okay, one more question.
Go ahead.
Yeah, go ahead.
Do you use Spark context to score Spark models?
We do. We do use Spark context. And I believe Vinay's demo actually may have showed it.
No, I mean, so for single row scoring, for real-time scoring, I think that throughput will be not sufficient.
Yeah, so Spark is actually, the question was, do you use Spark context for scoring models? Spark is actually very good for batch, right? I mean, the performance is off the charts. And that is one of the reasons why this work that we are doing, IBM and Hortonworks, is very important because there is local Spark in HTTP itself. And if you remember my 3-phase roadmap, the 3rd phase is when we'll be using Yarn as the resource manager. And especially for batch scoring, Spark is going to be phenomenal. And the performance that Spark gives around batch scoring is something that is very difficult to match.
Will you continue your thought on performance or the throughput with Spark context? Or what do you do for, shall we say, single row scoring? What do you prefer to do?
We actually, what we did, we wrote just a small library that takes the model out of Spark using Spark ML and scores the model without Spark context. So it's in order of magnitude faster and much more scalable, horizontally scalable.
Yeah, we can talk offline. Starting the next.
Yeah, so thanks everyone. Hope the session was helpful.
So we actually have one more talk from Yambo. So Yambo is an Apache Spark committer. He's one of the Apache Spark committers on machine learning. So he has a short talk around practical machine learning with Spark. So I'll give Yambo just a second to get set up.
Does he need power? Just want to work for him.
Okay, so let me just this.
Okay. Can I start? Yes. Okay. A quick talk.
So we'll transition to Yambo. If folks want to continue conversation, please outside. We'll kind of get Yambo going started, and for now we'll have questions at the end.
Okay. A quick talk. And then we'll back home. My name is Yanbo Liang, Apache Spark committer and staff software engineer at Hortonworks. Mainly Spark three parts. The first part is about what we do machine learning on a big data platform and the relationship between machine learning and the data platform. And then we walk through an example to how to build a machine learning pipeline on Spark with Spark. And then we talk about how Spark facing challenges from other machine learning libraries. As far as I know, libraries like TensorFlow or RStudio is very, very popular and widely used. How we can switch between different libraries according to your requirements. First one is, as we all know, we ingest a lot of data in the big data platform, such as you use Hortonworks data platform. We store data on HDFS or HBase, and Spark is a very wide, popular, very wide used framework for data processing, and we can also use it to do some machine learning job. Also, TensorFlow is another wide popular libraries. How we can use TensorFlow to train a model where the data is stored on the big data platform is a question we need to consider. And as data become bigger and bigger, the roles to involve into the problems get different. We need data scientists to work together with software engineers. What data scientists would work? They would to these scientists maybe have strong background about mathematics and maybe little background about software engineering. They maybe graduate from mathematics or statistics. They use very simple and friendly APIs to export data to create data science or machine learning pipeline and to train model to find the best parameters and then save the model. After that, the software engineer will take over the job and load the models from the data scientist produced and scoring on the model or make prediction based on the model. Maybe the new accept data to make predict is batch data or streaming data. Okay, so this is the overall pipeline for a typical machine learning workflow. First, we need to load data and do data selection, to feature selection, to do feature transform, feature encoding, and then we get features which was denoted or represented by vector. And then we can feed the features in a model training steps. Model training usually is the main focus for machine learning work. We know, as we all know, logistic regression or deep neural networks, both are model training. And then after we get a model, we selected the best model, and we can put the model into service to make prediction on new ingested data. So as depicted in these slides, only a small fraction of the whole workflow is actually the machine learning. It needs to first collect data and then do feature selection. Both of these works can be finished on the whole data platform. This picture is widely used. I devoted, it was the first released by Google, and last week I went to Spark Summit Dublin. A lot of other speakers use this picture in their slides. So as we all know, we need the whole data platform to help us to build the machine learning pipeline. So let's walk through which components or which open source project or systems can help us in the whole pipeline. First, we import data from like HDFS or AWS S3 or relation database system. After that, we get the data. Usually, we will join data with Hive or Spark. And then we do data exploration, do data sample. We can see a very simple examples. We will make prediction for a spam email or not spam email. Usually we collect the history email. Most of the email may be not spam. Maybe 80 or 90% they are not spam. So the label is usually very, very imbalanced. If we directly feed the data into a model, you will get a better model. If you have to similar work before, you will have sense. So usually we will downsample the data from the group which have more data. For example, if more data is not spam, we will downstairs them. Maybe we will sample 10% or even 1% from the whole data. Another way is we will upsample the data which is less. For example, the spam data is little. We can add some random noise to the data and make them make them more and more. So make the positive label and negative labels more even. So this is a very, very common use case in practical machine learning. So Spark can help us in this work. And then we will split the training and test the data set by some rules or just random. Spark have some APIs we will show later. After that, we will do feature engineering. Usually, the user provides rules can help us to do some transform or selections, such as one hot encoder. You can encode one category labels into several columns. It's very common used case. And some embedding skills like the word-to-vect, which is used for natural language process. It can get very, very good result for a lot of scenarios, and it's very easy to use. After that, we get features. We can do model training. Usually we have two typical ways. The first is the traditional machine learning models, and another is deep neural networks. Traditional machine learning models, including like logic regression or gradient boosting tree, or some recommendation algorithms. We usually use a library like Spark ML Lab, like SGBoost. And even the data, if the data is not so big, we can use sklearn or some single machine learning libraries. For the deep neural networks, the CNN is usually used for image processing. RN used for RN and RSTM usually used for natural language processing or time series data processing. The library is like a very popular TensorFlow or Big Deal is deep neural network or deep learning library built on top of Spark. So we will mostly talk about the traditional machine learning models. After that, we got the models. We will deploy the model and make prediction on batch or streaming data, and do experiment offline and online. I think we have talked about model surveying before, so in my talk we can skip it. Okay, let's give an example, very simple example. First, we have a data set. How use Spark to finish the work we just mentioned? First, we have a data set. The set is Spark is a table or data frame, has two columns. First is a text, is a string column, and second is label. We have 5 classes. So this is the classification job. And after that, we'll do feature engineering. We will first encoding the text column into the features. So usually for this, we will do 2 steps. The first step is split the string, get string array, and then we encode it using #intf for the features for double array. So we get features is a double array, and then we will feed the features and the label into the model training. We will get 2 columns, maybe the probability prediction and the prediction. After that, we have the models. We can use 2 columns. We can input these 2 columns to do model evaluation. We can judge a model is better or not according some metrics you specified, such as precision recall or AUC, ROC. So this is actually the real workflow may be more complicated than I illustrate. So this is just the basic workflow. So you can say it's just like we append columns to the data frame, and then we got a new data frame. We append another column to the data frame. So this is like a data frame flow on the machine learning pipelines. So, each step, the input is the data frame and output is another data frame. And in the next steps, the data frame produce the last steps is the input, and so on. So, okay, let's show some code. It's very simple. First, import data, very simple API. We can specify some format, such as ORC is the default format for Hive, and other formats like Apache, like CSV, JSON, or something like that. It's about a lot of format. And you can specify a directory which stores the data. We can get 2 data frames, and usually we will join them together. This data set is simple. So in real cases, you may need to join several tables or data frames. After we have got the joined data, we need to make it clean to drop some non-data, maybe not missing some values in columns. And then we select some columns which we will need. Since the joined data is a big and wide tables, we only need some of them, so we select the 4 columns. This is only a simple example. And then we have the tables. We will split them to training and test. We get 2 separate data frames. After that, we have one feature transform. We will assemble 2 vectors. The 2 vectors is, we can't say it here. We will predict the delay time according aircraft type, distance, and arrival delay, and the departure delay. So we will input the 3 columns as the input column for the vector assembler transformer, and then we get the features. And then we feed the features into the linear regression algorithms, specify some parameters like the maximum iteration number and the regression param, or elasticness params. And we construct the pipeline, use the pipeline to fit to get a model, and then we can get the model coefficients and intercepts. This is, and we finish the model training steps, we get the model. And then we get the model, we will evaluate the model according to matrix. Here we specify the matrix name is RMSE, is a matrix for evaluation for regression. So we can get the RMSE value for this model on the specified data. After that, we can specify another parameters in this algorithms, maybe max iteration equals to 20, or regression parameters to 0 or others, you can get another models. So you will retry this training several times. And a good idea maybe we first save the data frame before the model training, and we don't need to do work before this slice several times. We can save this data frame to external data storage and can directly load it. So this is tricky way to use it. And as we mentioned above, we may try different parameters. So usually we will run a lot of models and find the best models to use. So a traditional way, maybe we can specify the first parameters to get to make it run, and then we come out to walk around of park, or maybe grab a cup of coffee, and then we found, oh, it's finished, and we try another one. This is inefficient. Spark provides another APIs. You can directly specify the param grid, which means in this pipeline we have 2 steps. So the first step has 3 candidate params, and the second step have 3 candidate value for the param. So we can make it 3 plus 3 equals 9 candidate models. We will need to train 9 models and get the best models. So Spark provides API like this. We can directly feed this parameters in this pipeline and use the cross-validator to train the model, and you will directly get the best model according metrics. The matrix is specified here. We set the evaluator as your maybe your requirement. You need more precision or more recall or less recall. You can specify here, and then it will automatically get the best model, and then you can use it to transform on the data. So this is the algorithms that Spark has provided for us. You can directly use it. And if you have some customer requirement that can't finish by the algorithms provided by Spark, you can implement your own algorithms and plug into the Spark machine learning pipeline. And actually it has support you write algorithms in Scala, in Java, and Python. We finished the Python support in just we merge it into the rank. You can use it in the coming release, Spark 2.3. And since Python is very popular language for data scientists and machine learning engineers. So the last steps, several talks. Why Spark for machine learning? There are some reasons we use Spark. It's very practical and simplification and scalable. And it's good support for CPU intensive, since the Spark computing is lazy computing. And the data frame API used for pre-processing is very friendly and easy for data scientists, which maybe have less experience for computer science. And machine learning has a pipeline. You can rerun the pipeline very easy. You can directly export your pipeline to others, to your workmates. And there's some disadvantage about Spark, since Spark is MapReduce computing paradigm. So it's maybe not efficient to express some computing models, such like graph models. Is maybe less efficient. And we have less GPU support. And the Spark currently is machine learning algorithm libraries has little support for model 3. So actually the 3 libraries is which I think the most popular except Spark for machine learning. Scikit-learn is very experienced and widely used for several years in single machine year. And S3 Boost and LabGBM has win a lot of cargo competitions and used in a lot of internet companies. And TensorFlow is no doubt is most popular in the AI competition. So the last slide, that will show some of my not very careful or critical points to show we can use which library to solve which kinds of problems. Such as for image classification or speech recognition, we use deep neural network. For image, we use CNN, and for speech recognition, we use RN or STM. So maybe TensorFlow is the most suitable one for them. And for NLP, we have many two ways to processing. The first way is we use the word2vec to learn features and feed it into deep neural networks or linear models or some tree models. And another way is we use TF or IDF to learning features and feed them into these kinds of models. For recommendations, we can use linear models or tree-based models, or we can use some embedding ways to embedding ways usually is not too deep neural networks. And then we get some features and use RSTM to make recommendations of classifications. For graph models, definitely like RDL PageRanks based on MapReduce models are based on graph models. It depends on which libraries you use. And for some structured or semi-structured data in Hive, basic machine learning with skate-learn is still very popular since a lot of these kinds of data may be not so big. You can fit it into a single node machine. And if you can't, you can try use Spark or like S3 Boost. So this is mostly it's not very careful conclusion about what we can use. But maybe you can get some inspirations from these slides, I wish. Okay, thank you. Have any question? No?
What is the next release of Spark 2.4?
We will release Spark 2.3 maybe in 2 or 3 months. We don't have very detailed plans for Spark 2.4. 2.3 is mainly for vectorized Python UDF support, for more Python and R support, make it can parity with Scala, and we will make like cross-validation more efficient, make Spark streaming more run more fast. This is mainly work for Spark 2.3, and we don't have a very detailed plan for 2.4.
How about Spark ML itself? Any plans to support things like GPUs or?
Okay. I think from what I learned, Spark don't have a plan to support GPU.
See, the reason why I'm saying 2.4 might have 2.4 will have support for TensorFlow. TensorFlow will need GPU.
Actually, we have Spark has a separate product called which was initially developed by Yahoo. It's TensorFlow on Spark. And Spark community maybe leverage it. If you have some requirement to use it, you can directly use that. And in the Spark community itself, not to pay more efforts on this direction. I think so. Okay. Okay.
Any other
No
questions?
questions?
I know it's been a long night. So thank you, Yambo. So thanks, folks, for coming out for another meetup. We're looking to have a meetup sometime in the November timeframe, maybe around the deep learning topic. So stay tuned for the meetup page. I saw a lot of new faces today at the meetup. So for all the people who are new to the meetup, Thanks for coming out. I think some of the speakers will be around afterwards. So thank you. See you next time.
Oh.
Thank you.